Hello everyone, this is Miss Lindsay. Today we're going to talk about sequences and series as an introduction to that. So please take a moment, pause this video, go ahead and write down these definitions, think about them a little bit, and then we'll discuss them shortly. Okay, so what is a sequence? A sequence is an ordered list, and mathematically the domain is the set of integers, and it's typically positive. I do have a little typo there, but they're usually positive integers. We will talk about a couple different types of sequences, infinite and finite. Finite sequences stop, infinite sequences go on to infinity. And they are made up of terms. Sequences are made up of terms. We use n or k to designate the location of the sequence, so in other words, the term number. So a few more definitions here. So to add on to the n or k, so we have a sub 1. That is the value of a term when n equals 1. So in other words, this would be the first term. Then we have a sub n. That's the value of the nth term. Okay? And we also use a sub n to extend for our explicit equation for the sequence. So again, we can write sequences out in terms of literally listing each term, or we can use an equation to actually represent the sequence. Then we also have two other ones. We have a sub n plus 1 and a sub n minus 1. So a sub n plus 1 is the next term in your sequence after the a sub n, and a sub n minus 1 is the previous term before a sub n. So go ahead and take a moment, write these down if you didn't get those down, and again, think about what each of these values mean. So each of these sub n terms here, so a sub n, so if I actually had a sub 2, that would refer to the second term. Okay, so again, the n is referring to the term in the sequence. So go ahead and take a moment, write those down if you need to, if you didn't get those down, before you move on to the next one. Okay, so let's go ahead and take a look at this first example here. We have a sub n equals 5n plus 1, and we want to write the first five terms of the sequence. So you can see here a sub n, in this case, 5n plus 2, that is our explicit equation that models this sequence, and we're going to find the first 5 terms of that sequence. So again, this is my first term, a sub n, and a sub 5 is my fifth term. Okay? So what we're going to do when we find this, we're going to simply substitute in 1 for n. So we'd have 5 times 1 plus 2. So the first term would end up being 7. And then we're going to repeat this process for the second term, which is a sub 2. So 5 times 2 plus 2. And that would give us a value of 12. And then you can hopefully see when we do the third term here, if you're noticing a pattern here. Okay, so the next one would be 17. So the pattern, we started with the first term of 7, the second term of 12, third term is 17. So we are adding each time to this sequence a factor of 5, adding 5 each time. So if we take 17 and we add 5, we'll get 22. And add another 5, we'd get 27. Okay. So again, a sub 5 stands for the fifth term. The value of the fifth term is 27. I'd like you to go ahead at this point in time and go ahead and do the second example, find the first 5 terms, and then when you're done, go ahead and push play to check your answers. Okay, and take a moment, check your answers here, and if you notice in this case here, 2, 5, 10, 17, 27, in this case, we're adding 3, we're adding 5, we're adding 7, so the pattern is not as apparent as the previous one. Okay, and we'll talk about the differences in these different types of sequences as we move on. Let's go ahead and try another example. So here we're going to find the 11th term of a sub n equals negative 1 raised to the n minus 1 times the quantity n minus 1. So in this case, n will equal 11, so we'll substitute that in. Negative 1 raised to the 11 minus 1 times 11 minus 1. So negative 1 to the 10th times 10. Negative 1 to the 10th would then be positive 1 times 10, which would give us 10. So again, the 11th term has a value of 10. I would like to point out one portion of this, and that would be this term. Okay? Negative 1 raised to the n minus 1. I want you to take a moment, think about what that would actually do to a sequence. You could actually plug in a couple values too. You could do a sub 10, a sub 9, plug in some of them, just to see if it does have what that pattern would be. And hopefully you'll notice what it's actually doing. It makes it alternate negative then positive. So as it goes through the sequence, you're going to see that you have values that start off negative, then that would proceed to going to positive. And actually, I wrote that the wrong way. It alternates between positive then negative. Because if you did a sub 1, it'd be negative 1, 1 raised to the 0 power. Anything raised to the 0 power is going to be a positive. So in this case, it would be a value of 0. Okay? But what would make it start from negative then positive would be taking negative 1 and raising it to the nth power. That would make it start as the first term being negative, then alternating to positive. So that's something to remember in the future, what makes it alternate between, again, which one do you want to be positive first to negative, or negative then positive, but it makes it alternate no matter which one you're using. So go ahead and get out your sheet here that has a list of 13 different scenarios here. Let's actually find the nth term equation for these. So if I take a look at the first one here, I have a sequence of 4, 5, 6, 7, 8, ... So it gives me the first 5 terms. So if we take a look at that, is there any pattern we can see between 4, 5, 6? And yes, hopefully you see that we're adding 1 each time. Okay, so how can we actually come up with an explicit equation, what we call the nth term, or we also call it the general term as well? That's another term you'll hear. So we're looking for a sub n equals what? What equation can I actually write there to help us figure out the pattern? What do we want? Jump to the 20th term. Maybe we want to find what that is. Well, let's think about this a little bit. The first term is 4. The second term is 5. Again, we've decided we've added 1 between those. So how can I then take my n value here of 1 and make it equal 4? Well, I could actually take my value of n and I could add 3 to it. So in other words, if I say, okay, let me let a sub n equal n plus 3. Okay, so let's check this. Will this work? Okay, so if I do a sub 1, I'd have 1 plus 3. Yes, that equals 4. Does it work for my second term? So now I'd have my n value of 2, and I'd add it to 3. Yes, that gets me 5. Well, let's jump down to the fifth term. Will it work for that one? So now I'd have 5 plus 3. Yes, that gets me 8. So a sub n equals n plus 3 would then be the general term for our first example. Okay, so let's take a look at number 2. So again, hopefully you see here, we have negative 3 as our first term. We're adding 1 each time. So again, how can we come up with a formula? So our first term is negative 3. Well, if you take a look here and say, again, n equals 1, what can we do to get to negative 3? So hopefully you're looking at that and saying, okay, let me subtract 4. And again, test that theory. Plug in 2. Do you get that to be the correct answer? So we'll plug in, I'm sorry, that's a positive 2 minus 4. Yes, we get that to be negative 2. And if you check the fifth term, you get the exact same thing as what is listed in our chart. So our formula here would be a sub n equals n minus 4. Let's also take a look at number 3. In this case here, and number 4. Now hopefully you see a little bit different pattern in this one. 2, 4, 6, 8. We are multiplying each of these by 2. So in our case here for number 3, how can we write that formula where the first term is going to be 2 and our n value is 1? Well, hopefully you see if I multiply 2 times 1, so in other words 2 times n, I get that to be 2 for the first term. So let's check the second term. What if I do 2 times 2? Yes, that gets me 4. Third term, now I do 2 times 3, which gives me 6. So in this case, again, the general term would be 2n. Now how can we extend that to 4? Because now we're doing the odds. We've got 1, 3, 5, 7, 9. So in this case, actually, if you see that, we're taking this 2 value, we're decreasing that by 1. We're taking 4, we're decreasing that by 3. So we actually can just take this form and modify that by doing 2n minus 1. So again, I'm taking, that third term, I decreased it by 1. This term, I decreased it by 1. So again, we can test that by plugging in a sub 1. And there we get 2 times 1 minus 1, which would be 1. Check the second term. So it would be 2 times 2 minus 1. There we get it to be 3. And again, you can check all these too, doing a little bit of guess and check. So I'd like you to right now pause, finish the chart. When you're done, resume so you can check your answers. Okay, so go ahead and check the answers. And hopefully you're seeing a few patterns here. 12 and 13 are referring to the alternating between positive and negatives. And then let's go ahead and touch on one more part of sequences, and these are called recursive sequences. Recursive sequences are terms defined by the previous term. You must be giving the starting value. So you can see a couple examples here. We have this first example and this second example. So take a moment, go ahead and write those down. Write down the definition of a sequence and then push resume when you're ready to start the next example. Okay, so let's go ahead and find the first 5 terms. If you notice, they give us the 0 term. That is our starting value. They give you the 0 term. And the second one, they give you the first term. They can give you either or, but they have to give you a starting term. So we're going to find the first term. In order to do that, okay, what I'm actually doing is I'm taking this value of 1, I'm plugging in the previous term here to find my first term. So 2 times, well, what's the value of my a sub 0? Well, that's 3. So I'm using, again, that is my 0 term to figure out what my first term is. So in the second case here, when I'm finding a sub 2, it'd be 2 times, well, now I'm going to use this value of 1 because that's going to be my first term plus 3. So again, it would be 2. What's the value of my previous term, which is 9? Then I'm going to add 3. So I get that to be 21. So again, you're always using your previous term. The third term, 2 times, well, now this one would be a sub 2 plus 3. So it'd be 2 times, well, what's my previous term? 21. Then I add 3, which gives me a value of 45. Go ahead, take a moment, try that next example. I will finish these terms as well. Try to finish these, then push play when you're ready to check your answers. Okay, so here are the remaining answers, and we will touch base again on this tomorrow. Okay. So here is your homework for the first day of sequences and series.